G'day. This video is one in a series on hands-on maths, and today we're looking at probability with blocks. To get the full benefit of this video, you need 4 blocks, as you'll see. I have a worksheet, and when I run the workshop, all the students have a worksheet, and this is downloadable from my website, mathwithgeoboards.com. It's double-sided. You can print it back to back in black and white. First of all, I want to start with a review of and or. And here we have a waitress, and she's asking a question. And the question is, tea or coffee? Now, a mathematician, he might hear that and say, well, tea or coffee really means tea or coffee or both. Tea and coffee looks like this. And he says, do you mean tea XOR coffee? Because XOR means tea or coffee, but not both. And the waitress says, yes, that's what I mean. Tea XOR coffee. As I said, we're going to look at probability using 4 blocks. First of all, permutations, combinations, and then some random choice problems. Permutations. Caleb Coutinho used to teach very young students, Year 5 students, about permutations using his Cuisenaire rods. And he would ask the students to make a train from the Cuisenaire rods. The order of the carriages was what varied. When it comes to permutations, students sometimes have a problem. And I want to go over to the whiteboard and show you what that is. Here are the 6 permutations for 3 blocks. And the confusion arises when the blocks are in reverse order. I'll just take 2 sets to show you what I mean. You see in this pair of permutations, I have red, green, yellow, and yellow, green, red. And this is where the confusion arises. But if you put the train engine at the front, then you see that the carriage order of red, green, yellow is different from yellow, green, red. And this is Caleb Coutinho's way of explaining it. And there we have 6 different carriage orders. One carriage, you can only have 1 arrangement. But with 2, you can have 2, of course, green, blue, and blue, green. With 3, you can have 6. And 4, there are 24. And 5, 120. 6, 720. Our job is made easier because in each case, it's just that number of things factorial. That is the general rule. N number of distinct things can be arranged in n factorial ways. To follow the worksheet, I'm going to give you 25 seconds for each question to find the answer. Question number 2 is simply, how many ways can we order 4 blocks? And we've already covered that actually in our table on the worksheet, 4 by 3 by 2 by 1, in other words, 4 factorial ways, 24. Question 3 asks, if red is always first, in how many ways can we order the 4 blocks? When doing probability diagrams, there are different ways of doing it. I like this one. If I have 4 possibilities, I make 4 boxes. And if one of those possibilities is already decided, then I put whatever that is in the box. So you see there, red goes in the first box, and I put a 1 over the top. Then for the next box, there would be 3 possibilities. And the next one, 2. And the last one, 1. And the answer is 6. Next question. In how many ways can I order the blocks if red is not first? And the hint is to remember the question we've just done. Well, we can take all the possibilities and subtract red first, which we did in question 3. That would be 24 minus the 6 possibilities. And our answer is 18. Next question. Yellow first or last? Now remember here, there's only one yellow, so it cannot be both first and last. In other words, the two situations are mutually exclusive. And if they're mutually exclusive, we can add them. It's yellow first plus yellow last, which will be the same as red first. 6 plus 6 equals 12. The answer is 12. Next question. Yellow neither first nor last. We could take all possibilities and subtract yellow first or last from question 5. The answer is 12. The next question, red and blue together. Now there's a trick here that you should know. The trick here is that when you have two things together, you treat them as one. It will be 3 factorial But what we've taken together, the red and the blue, can also be blue-red. So we must multiply by 2 factorial. 3 factorial by 2 factorial is 12. Next question. Red and blue never together. Well, in question 7 we worked out red and blue together. All possibilities minus red and blue together will be 24 minus 12 equals 12. Next question. Red and blue together, red never next to yellow. We do already know red and blue together. You have to work out just when red is never next to yellow. So we can take red and blue together, which we already know is 12, and subtract the situations when yellow is next to red, when red and blue are together. So that would be blue, red, yellow, or yellow, red, blue, and that happens in 4 situations. It's red and blue together minus 4. 12 minus 4. The answer is 8. And list all the permutations, and there are 8. Red on one end and green on the other. It's an intersection, as the diagram indicates. You can't just have red on one end or just have green on the other. It must look like this, or like that. So the answer is 4. Run a check on that by listing all the permutations. Question 11, red on one end or green on an end. In other words, it's union. We can have one or the other or both. That's really all possibilities minus red and green in the middle. Because when they are not in the middle, one of them is on an end. In these situations, there are 4 of them. So that is 24 minus 4. The answer is 20. All the permutations. Red on an end, XOR green on an end. We can have red on an end or green on an end, but not both, as the diagram illustrates. We can use what we've previously worked out in questions 11 and 10, that 11 was red on an end or green on an end, And question 10 was red on an end and green on an end. If we subtract one from the other, we get 20 minus 4. The answer is 16. And there they are. Four blocks in a circle. Well, there's a formula for this. Makes it easy. And the formula is the quantity of n minus 1 factorial. So here we have 4. Minus 1 is 3. 3 factorial. The answer is 6. The diagram lists the 6 possible permutations in a circle of 4 distinct things. This is a trickier question. 4 blocks in a circle, red and blue not next to each other. We could take always in a circle and subtract when red and blue are next to each other. So they would be next to each other in 2 factorial times 2 factorial ways, which is 4 ways. So 6 minus 4, the answer is 2. Again, if we let 1 equal red and 2 equal blue, we can see from this diagram there are only 2 situations when they are not next to one another. We now move to making selections from the 4 blocks. So I want to select 2 from the 4 blocks, and order is important. In other words, 4p2. If I have 4p2, I can use the formula for permutations. That is the formula. And the answer is 12. But I want to ask, is there an easier way? And there certainly is. You start with n factorial, but you only use the k number of factors. So in 4p2, I use only the first 2 factors, 4 by 3. Answer, 12. And now, if I want to select 3 from 4 blocks, and order is important, well, that's 4p3. Well, if you just use the method I explained, you can very easily get the answer. First, we'll use the formula. And the answer is 24. But I use the easy way. N factorial to the first k number of factors would be 4 by 3 by 2, and the answer is 24. Now we're moving to combinations. I want to choose 2 from 4 blocks, and order is not important. So that would be 4c2. Again, I can use the formula. And the answer I get is 6. Is there an easy way for combinations? There certainly is. It's Pascal's triangle. On the right is Pascal's triangle, and on the left are the combinations you can set out to match Pascal's triangle. If we were working out 4C2, we go to row 4 to the second term, and there's the answer, 6. Note that when we do this, the first row is row 0. First combination in any row is the row number C0. Pascal's triangle is very useful for combinations. I taught students who would go into their exams and write out Pascal's triangle on their scrap paper. They knew it by heart, and then they would use that to answer questions about combinations. Why not use a calculator, you might say? Well, you can make a mistake using a calculator. But Pascal's triangle is never wrong. Some more examples then. 4C3. There's the answer, 4. 4C4. The answer is 1. 4C0. Yes, there's one way to take no things from 4 things. 4C1. Well, there's 4 ways to take one thing from 4 things. Another handy trick with combinations is to remember that NCR equals NCn minus R. And I give an example here. 20C18 equals 20C2. We're moving on to random choice. This is without replacement. You can have random choice with replacement. With blocks, it's typically without replacement. Put the blocks in your hands and shake them around, and then I ask you, well, what is the chances of drawing a red if you only take 1? Well, that would be a quarter, or a fourth, or 1 out of 4. Again, what's the chance of a red or a blue taking only 1? Well, that would be 2 chances out of 4, or 1 out of 2. Now I'm taking 2, red then blue without replacement. Well, to take the red would be a quarter, and then there are only 3 left. And I want a blue, a third chance. So that's 1/12, or 1 out of 12. Now I have 8 blocks, and I ask what is the chance of drawing a red? 2 out of 8, or 1 out of 4. Blue or green, taking 1 with 8 blocks. Well, to draw a blue, there's a quarter chance, isn't there? And a green is also a quarter chance. So if we only need to draw 1, we can add those 2 possibilities and get 4 out of 8, which is 1 out of 2. Now I ask you blue, blue. The thing to do is to take it one at a time. So for the first blue, there's a quarter chance. Then for the next blue, there's 7 blocks left and only 1 blue. So that's a seventh. And we multiply a quarter by a seventh. It's 1/28, or 1 out of 28. Next question. Any two of the same colour? Again, we take it one by one. The first one, it's 1. I can take any colour. But the second one must match the first one. There'll be 7 blocks left, and only 1 of the first colour will remain when I come to choose the second. The answer is 1/7 or 1 out of 7. Now I ask you any two of different colour. Again, take them one by one. So for the first one, I can take any colour. That's 1. And for the second, there'll be 6 there of different colour to the one that I chose first. So that's 6 out of 7 chances. 6/7. Question like the earlier questions. How many ways can I order 8 blocks if there are repeats? 2 red, 2 blue, 2 yellow, 2 green. I can order 8 things in 8 factorial ways. But I must divide by the number of repeats I have. That is 2 factorial, 2 factorial, 2 factorial, 2 factorial. 8 factorial divided by 16 is 2,520 ways. This sort of question is often asked about letters in a word. And if we go over to the whiteboard, I'll show you a very well-known example. One question you find in many maths books is, how many ways can you order the letters of the word Mississippi, which is the great river in the USA? Well, it's a similar problem to the one on the worksheet. First, we count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 11 factorial divided by the repeated things factorial, 4 I's. 4 S's. 2 P's. Now it's time to reach for the calculator. It's 34,650 ways we can order the letters in Mississippi. Just remember that all the S's are identical, and all the I's are identical, and the 2 P's. Okay, back to the worksheet, and question 31 is, how many ways can I order 8 blocks in a circle if there are 2 red, 2 blue, 2 yellow and 2 green? Well, that will be a quantity of 8 minus 1 factorial, 7 factorial, divided by 2 factorial, 2 factorial, 2 factorial, 2 factorial. And the answer is 315 ways. Now here we have a tricky question. If I have 2 green, a blue, a red and a yellow, how many ways can I select 2 blocks, order is important, from those 5 blocks? Note that dividing by the number of repeats factorial does not work when you're making a selection. it only works if you're ordering all the blocks. Well, the answer is 4p2 plus 1, which is 13, but I'll explain that on the next slide. There is no difference between green 1 and green 2. That's going to be 4p2, but there's one extra, green green. And that's it. So it's 12 plus 1. The answer is 13. This last question is about choosing pairs. Now, some groups in my workshop have blocks and others have triangular prisms. I ask, how many ways can I choose one block and one prism? Well, it's 16 ways, and the explanation for that is it's the fundamental counting principle that if I have m kind of things and n kind of things, I can combine one of each in m by n ways. There's 4 blocks and 4 triangular prisms. That's 16 ways. Right, that's the end of this particular presentation and this workshop. There is some contact details. I have a YouTube channel called Math with Geoboards. I hope you got something from this hands-on maths presentation, because it truly is the best way to learn.